Let's get started. I'd like to introduce Kaizen's own Global Product Line Manager, Chuck Sexton.
Thank you, Cassie, and hello, everyone, and thank you for joining today. My talk is on parts washing, chemistry, and process. Too much or too little. Either one can cause problems. And this presentation it addresses aqueous cleaning chemistry in a wash process where you would typically have a wash and at least one rinse stage. Why clean? In the manufacturing world, removal of oil, chips, and other soils for the next operation. We normally call this in-process cleaning. Cleaning prior to coating, cleaning for inspection, final cleaning for packaging and assembly. The process requirements for an effective cleaning process, there are others, but I've sort of boiled them down to 4. Cleaning performance, so the cleaning process has to clean your parts well enough to meet your cleaning requirements, be it a millipore particulate spec or a residual organic test, compatibility with substrates. So we can't use a high pH caustic cleaning product if we're cleaning aluminum. Process efficiency, environmental impact, worker safety. These last 2 items deal with one of our main objectives, which is to develop the safest possible process for our customers that still cleans their parts to their requirements. This slide shows the sort of 5 cleaning mechanisms, and we add different chemical components to accomplish these different mechanisms. The first is wetting, where we're lowering the surface tension of an aqueous cleaning stage so that the fluid can penetrate in between the soil particle or droplet and the part itself. Deflocculation is a process of taking larger particles or droplets and breaking them into smaller particles where they're more easily removed. Emulsification is where we're tying up and dispersing oil droplets that would normally not be able to be dispersed in a water phase. Solubilization is where we're removing the contaminant by dissolving the contaminant, like salt in water. Chelation is a process where we're adding chelating agents that tie up the metal ions. A good example is removing aluminum oxide from aluminum parts. A really nice way to look at parts washing is parts washing equals soil management. So we're removing the soil or contaminant from the parts, but then on purpose, we need to do something with the soil. Cleaning chemistries, aqueous cleaning chemistries can be classified as two broad categories: emulsifiers and non-emulsifiers, or oil splitters. And then you can further categorize these products by their pH. So the beaker on the right shows an emulsifier, and the oil that was added to this cleaning chemistry stayed in a stable emulsion. The cleaning chemistry on the left removes the oil from the parts and then releases the oil and allows it to separate to the surface, where the oil can then be removed from the cleaning process, usually by gravity separation in a decanter, often called oil-water coalescers. This is an actual operating coalescer where we turn the coalescer off, which you can see on the left, and the oil built up, and then we turned it back on for a couple hours, and it very effectively removed the oil from the surface and thereby from the overall cleaning process. So we're adding chemistries to the wash and the rinse stages, and we need to know how much of these chemistries we've got in these stages. The 3 primary methods that we use are conductivity, refractive index, and titration. This is a good example of a conductivity chart for one of our alkaline products, 6319, where we've measured the conductivity on the left as millisiemens and related that to percent cleaning chemistry on the bottom axis. And in many cases, this is a very accurate way to control your cleaning chemistry. concentration, we always find that our customers have a smoother operation and spend less money on cleaning chemistry when they're automating the chemical addition. So this system I've shown on top here is a simple proportioning pump. The incoming water makeup drives a piston pump, which then pulls the cleaning chemistry out of the cleaning chemistry reservoir at a preset rate and adds that ratio mix to the wash reservoir. The system shown on the bottom is a bit more sophisticated. Here we're actually measuring the concentration in the wash stage or rinse stage by measuring conductivity, sending a signal to a metering pump, and adding the chemistry accordingly. Too little chemistry in the wash can cause problems. The first and most obvious is probably incomplete soil removal, where we're not removing oil or buffing compound or carbon, whatever the contaminant is well enough. Flash rusting. We often add corrosion inhibitors to the wash chemistry. If you don't have enough chemistry, you can corrode in between the wash and the rinse or immediately after leaving the rinse stage. Or you can have excessive foaming. We add defoamers to many of these cleaning chemistries, and you can end up with a problem like this. And a customer told me about 15 years ago on the phone one time, he said, "You don't understand. I Love Lucy foam. And foam in a process like this is terrible. You end up cleaning the floor around the washer a lot. And so if you don't have enough cleaning chemistry in the wash stage, you can end up with a foam problem." Our Southeast regional manager, Jason Shorts, actually gave a really good presentation in another Tech-to-Tech session about 2 weeks ago. Too much chemistry in the wash can cause problems as well. Cleaning chemistry, film, and spots by not rinsing well enough. Excessive carryover of wash to the rinse, where you load up the rinse and end up with spots. And high costs, where you're buying chemistry that you don't really need to buy. This is an example of parts where we used a corrosion inhibitor and cleaning chemistry in the wash stage. It didn't get rinsed off well enough, and you ended up with white spots. White spots are really typical of having a residue left from the cleaning chemistry and the corrosion inhibitors. Too little chemistry in the rinse can provide poor protection if a corrosion inhibitor is being added in the rinse. Incomplete drying. Many of our products contain drying aids, which actually assist drying the parts in the drying stage. And incomplete cleaner removal if you're not cleaning, if you're not rinsing long enough. This is a good example of parts that we placed in a humidity chamber for 10 days, which simulated 90 days sitting in a unair-conditioned warehouse in the summertime in the Midwestern United States. You can see what happens when we don't have enough corrosion inhibitor. Too much chemistry in the rinse can cause spots and film from the non-volatile components in the rinse drying on the parts. And corrosion inhibitor from removal of corrosion, corrosion can result from removal of corrosion inhibitor applied in the wash stage. And I like this comment because often customers think that if you rinse for 2 minutes, that's great, and 10 minutes must be even better. And that's not always the case. This is a good example of stainless steel tubes that were then hydroformed to produce Corvette frames. And we have a corrosion, these are aluminum tubes. We have a corrosion inhibitor in the wash that protected the aluminum up to about 4 minutes. And after 4 minutes in that second stage, which is a clean water rinse, you could actually watch the aluminum tube start to turn dark. So you can rinse too long. In conclusion, your wash and rinse chemistries and cycle times need to be in the just right range. Now I'll turn it back to Cassie, and thank you so much.
Thanks, Chuck. If you'd like to discuss this topic further, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone schedule a follow-up with you as soon as possible. Again, we thank you all for taking time to join us today, and we hope to see you again soon. Stay safe, stay healthy, and have a wonderful day.